Hey, also in last class, in our last lesson, we talked about using trig functions to find missing sides in right triangles, using those relationships. And today we're going to use those relationships to find angles in right triangles. So first we need to be able to evaluate these things just by using our calculator. So I'm going to get my calculator out, and I want to find what is this measure of theta, that angle that if I did the cosine of that angle, it would be 0.9962. Put another way, if I had a right triangle and I knew its adjacent side and its hypotenuse, if I wrote the fraction of those two values and then found out whatever decimal that created, it would be 0.9962. So I'm trying to find the angle that will be related to those two side measures. So we have what's called an inverse function. If you look on the calculator where cosine is, above it in blue, it says cos to the -1. That might be a little bit hard to see right now on your screen, but we can look at that in class. And so to get that function, we would press the second key, and you see this cos to the -1. That's the inverse cosine. It's sort of like how adding and subtracting are opposite operations, and multiplying and dividing are opposite operations. Squaring and square rooting are opposite operations. Cosine and cosine inverse are opposite operations. And so if I show that, I want to do the cosine inverse of both sides of my equation. And when I do that, on this side, cosine inverse and cosine cancel. Like I said, just like a square root and a square cancel, these two functions cancel. So what I'm left with on the left side is that angle I'm looking for, theta. And so in our calculator, we make sure that we are in degree mode. I'm not, so let's go change it to degree mode. And then I'm going to do my second cos to get that inverse, and I'm just going to plug in that decimal. And I'm going to round to the nearest degree, so the cosine inverse of this 0.9962 is about 5 degrees. So in a right triangle with a 5-degree angle, if I took the cosine of that angle, it would be 0.9962. And so we can do the same thing here for this tangent. I have a tangent inverse, and so I'll do the tangent inverse of both sides. And on the left side, that's going to leave me with that angle I'm looking for, theta. So let's actually do the tangent inverse. Second tan, 0.5543, and I get close to 29 degrees. I'll do one more. Sine has an inverse function, sine inverse. On the left side, that sine inverse and the sine are going to cancel, and I'm going to be left with just my theta. And so I can go to my calculator. Second sine gets me sine inverse 0.1736. And I'm going to say that's approximately 10 degrees. So I want you to go ahead and pause here. Try this one if you have a calculator at home. I believe if you turn your phone to the side, you should be able to get your trig functions and even your inverse trig functions. So to get theta by itself, we need to do tan inverse of both sides. The left side's going to leave me with just theta. And then if you do tan inverse of this 4.7046, you get something close to 78 degrees. And so now we're ready to take this and apply it to right triangles. So here I have a right triangle. In the last lesson, we would have known how big one of these angles are, and then we would have used one of the sides to find a missing side. And so in this case, I know two sides in this right triangle, and I'm looking to figure out how big is this angle. And so what I need to do is figure out which sides do I have. So I have the opposite side. And then I also have the adjacent side, the leg that is right next to the angle. The function that has opposite and adjacent in it is tangent. So I know that the tangent of an angle is related to the opposite side divided by the adjacent side. And so now let's plug in what we know. Theta here is question mark. My opposite side is 10, and my adjacent side is 14. Now I want to cancel this tangent out over here so I can get question mark by itself. So I need to do the tangent inverse of both sides. When I do that, tan inverse and tan are going to cancel. So I'm going to know what question mark is here in a second. And again, I can go back to my calculator and I can just do second tan and just put that fraction right in there. 10 divided by 14. No need to change it to a decimal. And I'll round this to 36 degrees. So the process kind of when we're working with trig functions is always the same. Little tweaks, so I guess I should say similar. We need to establish which sides we have. So I'm interested in figuring out how big this angle is. So I have the opposite side. And then I have the hypotenuse, that side across from the 90, the longest side. Opposite and hypotenuse tells me I have a sine relationship. And so I'm plugging question mark in for the angle, 38 for opposite, 40 for hypotenuse, and now I need to do the inverse of both sides. Again, when I do the inverse sine of sine, those things cancel. And I'm going to be left with question mark on the left. That's the thing I'm trying to figure out. And then I just go to my calculator. Second sine, 38 over 40. So this angle is about 72 degrees. Let me do one more with you. Again, stick with the same process. I want that angle. I don't know my opposite side, but I do know the leg next to my angle. That's my adjacent. And I know my hypotenuse. Adjacent and hypotenuse tells me, hey, you can use cosine. I plug in what I know. And now I need to do the inverse cosine on both sides. So I'm left with question mark. And then I can go to my calculator here. No need to change that fraction to a decimal. Let's just do the second cosine of 23 divided by 36. And we'll round that to 50 degrees. That's close to 50 degrees. So I have a couple here I want you to do. I want you to pause. I want you to actually try and solve these. And then I will, if you press play, I'll reveal the answers. I don't have the work shown, but if you have questions about them, obviously we can do that in class together, no problem. So go ahead and pause right now, try these two, and then I'll show you the answers. So I hope you pause and try these on your own. If you didn't get the same thing as me, make sure you ask me for some help in class, and I can show you how I arrived at these two answers.